So in this video we're going to be looking at points on a line, finding out if a point is on a line and then actually finding other points on the equation of a line. So you might be asked a question, is the point 1, 2 on this line y is equal to x plus 1? So this 1 represents the x value and the 2 represents the y value, and you plug these numbers into this equation here and to see if it works out. So is y, which is equal to 2, is 2 equal to x, which is equal to 1 plus 1? And that's true. Yes. So therefore the answer is true. Yes. This point is on the line. Let's have a look at another example. So is 0, -1 on the line 3x plus 2y plus 2 is equal to 0? The first thing I point out is you'll notice that it looks slightly different in this format. But it is the equation of a line still. So again, the same thing. This is x value, this is the y value. Plug them into this. So 3 times 0, that's going to give me 0 in a second, plus 2 times, well, y is -1, plus the 2, is that equal to 0? We're asking that question. Is that equal to 0? And I've got 0 minus 2 plus 2 is equal to 0, and it's true. So yes, it is also true that this point is on this line. Let's look at one more example. All right, let's see if this is true. Is 1, 3 on the line y minus 2x equals 4? Again, a slightly different format of line as well, but still the same thing. This is x, this is y. Plug them in. So x is equal to 1, y is equal to 3. So we'll start off with the 3 minus 2 times, well, x is equal to 1. Is that equal to 4? Question mark. 3 minus 2 is equal to 1, and 1 is not equal to 4. Okay, so therefore it's false, not true. Now the second part is, can you use the equation to get points on a line? Okay, so you might be asked to do something like find 2 points on the line y minus 2x equals 4. So what I'm going to do is I'm going to let y equal 0, and that means that 0 minus 2x is equal to 4, and that means that minus 2x is equal to 4. Divide across both sides by minus 2, and that means x is equal to minus 2. So my coordinate, my point, is minus 2 comma 0. That's my x coordinate and my y coordinate. I've got a point on the line. To get another point on it, what I might do is I can let x equal 0. And when I do that, I'm going to go y minus 2 times 0 is equal to 4. And that means y is equal to 4. And that means my coordinate now is going to be 0 comma 4. I don't have to use 0, x equals 0, y is equal to 0. I could let equal to some other number. And very briefly, let x equals 1, for example. Well, then I'm going to get y minus 2 times 1 is equal to 4. Y minus 2 is equal to 4. Sorry, y. That means y is equal to 6. So this coordinate is going to be 1 comma 6. Let's have a quick look at this line, y minus 2x equals 4, and see if these points are all on it. So here's the line, y minus 2x equals 4, this green line here. Is 0, 4 on it? There's 0, 4, yes indeed it is. Is minus 2, 0, minus 2, 0, yeah, that's on it as well. And 1, 6, 1, I'd have to go up a little bit, hang on. So 1, 6, and it's on it as well. I just want to end up by saying a few words about which values are best to put into your equation of a line. I start off usually with saying let y and x both equal to 0, for the obvious reason that if I let y equal to 0 here, the y goes to 0, I'm just left with minus 2x equals 4. So I get a value for x very easily from that. If I let x equal 0, again the x goes to 0, I'm just left with y is equal to 4. Again, another very easy point. But I don't have to use 0 and 0. I can use any value for x or y. If you look at this brown line, you can see that every point on this brown line will have an x value and a y value. If I let y equal to 5, I'll get this x value here. If I let x equal to 8, I'll get this y value here. Equally, if I go negative, if I go negative 4, for example, if I let x equal to negative 4, I would get this value here. So you can always put any value you like in, but it makes sense to put easy values in like 0 and 1 and minus 1 and things. Okay,